We have to implement program today. You are doing program with me. So be ready with your device. Okay, we are starting. Good morning everyone. Today we are going to see implementation of tree traversal algorithm. So in this tree traversal program, first we should know the node part. Node part means where we are going to insert the element. And as per the tree should have a data part, its left child and right child. So these three parts should contain in structure. So this is your structure node and this is the part of structure. So every node will contain these three parts. Middle part is data, then left child and then a right child. So every node of tree will contain these three parts. So after creating this node, we have to create actual node, means actual value we have to insert into that node. We have to allocate the memory for the particular node. So for that reason, we are going to write this function, create node function. And in this function, we are passing value through void main. So this value will be your data of particular node. So here in this line, we are going to allocate memory for the particular node, for single node. Using this line, we are creating single node. Only memory is allocated here. Value is not assigned. So it will be like this. So using that code, this is your code. This is your code. Using this line, we are going to create memory allocation for the particular node. So if this is your node, this one is your node. So for this node, we will create the memory. We will assign memory location for this particular node. Suppose 1001 is the memory location we got for this particular node. So using this line only, we are getting the address of particular node, nothing else. So after allocation, after memory allocation, after that we are going to insert the data. We have the structure. This is our structure. In this structure, which part is there? Data part, left child and right child. So for these three part, we have to assign value here in this part. So new node data is equal to value. This value we are passing from the void main. Suppose we have passed from that is 10. 10 is the value we have passed from there. So after that line, that value will be assigned to node. New node data is equal to value. So here in this new node, we will assign the value. The next line is new node left is equal to null. So this side, left child, it is null means this particular node doesn't have any child. Same new node right is equal to null. Same this side, this particular node doesn't have left as well as a right child. So at this left side and right side, we will write null. Here is also null and right side is also null. So this is our first node. Every time whenever you will create node, same structure will be created. This type of structure, only value will be different. So using this function, we are going to create this node. One node will be there, After that, we are going to pass the value for this node, and left and right child should be null initially. After some time, we are going to insert the left child and a right child. So using this function, we are going to create that node. Then after some time, we feel that we should have a left child as well as a right child. So we will write separate function for that, inserting left child as well as inserting right child. Here also we are going to use the create node function. Same function, this one. We are calling this function only, but who is calling that? Root left child. So root left is here, this is a root, left is here. So here we are going to create new node using root left function. From the void main only we are passing value here, that is 20. And as per the node structure, every time whenever you will create node, its left and right should be null. And next time we are going to insert value to left as well as right. Same way we are going to create node at right side. So this is the explanation of program, how this program is going to work. After that, here it is a main function. Using this function only, we are going to execute our program. Without main function, we cannot execute any program in C language. So this is the starting body. From here, we are going to start our program. So in this first struct node star root, here we are going to create our root node with the value 1. After that, here we are calling left child with the value 2. Here right child with the value 3. Again we are creating a left child, again child for left child. So this is the 4. So we will see one by one each and every line in implementation part. After creating tree, we are going to show in order traversal, pre-order traversal and post-order traversal of that particular tree. So we will start from first.
Ma'am,
Yes.
ma'am, can you and let the other students to enter? Thank you, ma'am.
Okay, those who are having PC with Turbo C, they can join, they can start with their Turbo C. Who is not having computer or Turbo C, they can use online compiler. Type
Ma'am,
in,
can we use both blocks?
yes, yes, you can do there also.
Okay, ma'am.
So those who are not having Turbo C in your PC, they can use online compiler. So I am writing here online C++ compiler or C compiler. You can write anything. So till it is loading, you can write the header files. Header file, stdio and stdlib. Write only these two parts. Hash include stdio and hash include stdlib. If there is any doubt in each and every line, you can ask me. What is use of header file? Stdio and stdlib. We are using here two header file. What is
Ma'am, they have all they have predefined function which we are using in program. That's why we have to do.
yes. This printf, scanf, these are the functions are written under this stdio.h. Standard input output and printf and scanf. These are the functions which are used for taking input as well as showing output to the user. So we are using this stdio.h header file and stdlib header file we are using for memory allocation. Here we are allocating memory using malloc function in this. So this malloc function is written under this stdlib. That's why we are including these two header file stdio as well as stdlib. So this is the online compiler. Here we have to choose the language. See, there are many languages are there. We have to choose Turbo C. This one. First part is our header file. After that, create structure of node. This one. This thing you have done in linked list also. In linked list also, we have to create structure like this. So struct node. Then this is the part of structure. That particular node. What are the requirement of that particular node that are coming inside this? So this is the node structure. In this structure, struct is the keyword, node is the structure name. So using this structure name, and this is the part of the structure, integer data, struct node star left, struct node star right. After completing this, tell me, I will tell you next part of this program.
Done, ma'am.
What is this? Can you tell me? Struct node star left.
Ma'am, we are giving the directions to the we will put in. We are assigning them the directions that this will go at left and this will go at right.
No, I know this part integer data means this particular data will contain integer type of value. Left is going to contain. You should know all this part. What is this? What this line is? What this line is? So what this left is going to contain? As
All
this
the
data
values,
is all
all the
the
values which are in left part will contain.
see this type is called as a self-referential structure. You have this concept self-referential structure. When the particular structure is pointing to itself, see, you can see here this structure name and this. This is one data type, user defined data type. These two names are same and here we are using pointer. So this is a self-referential structure. Remember this thing. In linked list, in tree, we are using this structure. Self-referential structure. This left and right is going to store the address of particular node. This node. We are going to create particular node. And this left means it is going to store the address of left child and right is going to store the address of right child. Address of right child or left child means particular node only. Particular this node only. That's why we have written data type struct node. And it is going to store address. That's why we have taken here pointer variable. So this one will contain address of left child and this is contain address of right child. So next point is now we have to create the node. On the basis of this structure, we have to create node. So for that, we will write the code. Don't write comment. I have given it for help only. Start from here. Struct node star. Here we are going to create node and node is of type struct node. That's why we are taking here data type struct node star. Which type of value this function is going to return? Here we are going to return new node. New node means that particular node and this particular node data type is struct node. Node is the user defined data type. That's why we are taking here struct node star. This is function name create node. Here we are going to create new node and in that new node we are going to pass the value this data part. So this data part we are passing here as an argument to this function. So after this line, open the function. Then using this line, we are going to create a blank node. I have shown in the Word file that blank node without value. Here only we will get the address for the particular node. Struct node star is the data type. Then here is new node. We are going to create new node. That's why I have taken new variable name for this node. New node is equal to malloc. Here we are going to allocate memory for this new node. Which for which we are allocating memory and how much size required. That size we are getting from here. Size of struct node. So using this, we are going to allocate the memory for the new node. Here blank node is created. Now blank node is already with us. So next insert the value into that node. So new node data is equal to value. Then this is our first node. That's why it should not have left and right child. So initially we will keep it null. New node left is equal to null and new node right is equal to null. Now our node is created, so we are going to return that new node into void main. Through void main we are going to create this node. So this is going to return into the void main only. End of the function. Done.
Ma'am, wait 1 minute.
Okay. So for creating any tree, this you can use this function, create a node. Every time we are going to create node, after that we will apply any formula. For example, if you want to do pre-order, that for that reason we will write separate function. But for creation of node, this is the code. Done.
Yes, ma'am.
Now we will see void main part first. Then we will add other nodes. We will see first this node is created or not. So right there integer main, integer main create root struct node star root. So here we are going to create a root, that is our first node, using this create node function with value 1. So using this line we are going to call this function create node function, and that one value is going to store into this value variable. Accordingly this node is going to create. And after that, when a return new node, this line is coming, that time this address of this new node is going to return into this root variable. We are returning value here from this function. And if you are going to return value, we have to store that value somewhere. And what is the data type of this new node? Struct node star. Same data type should be here. Struct node star. Done this part, integer main function.
Yes, ma'am.
Now when you will execute this program, it will not show anything because we have not shown any printf statement here. But you can check the error. If there are any syntax error, then we can correct here only. Otherwise, it has to show blank thing. See here, I am not getting any output because printf statement is not there. But I am not getting errors. So same thing, you also check. Are you getting error or not? So after that we will see how to print this root value. We will check first value only. After that we will insert left and right child. Check your output. Maybe there is a error that root is assigned value but never used. That is not error part. We are going to use the root in the next line. Done?
Ma'am, I am getting one error.
What?
I am getting one error.
What error?
Invalid conversion from void to node.
Okay, here. Here you are getting.
Yes, ma'am.
Here
Ma'am, we
you
have
here,
to write that null all capital.
yes, null in capital.
Ma'am, still that error.
Same error.
Yes.
Here write star at this line and then check. Initially I was also getting the same error, but after some time it was gone.
Ma'am, same error.
बाकी के स्टूडेंट
No, ma'am. No error.
इसके sharing check your compiler then. Which compiler you are using? Turbo C,
Save, save C, save C++.
C++. Don't use C++. C, Turbo C.
Okay, ma'am. I will have to download.
Or check online like this. Online compiler. For now, you can do like this. Afterward, you will check offline. Okay. Next, once this is completed, now we have to show this root to user that we have created this root. One number. We have created this one root. We have to show this value to user. That's why we are using here different traversing functions. That is in order, pre-order, post-order. Now we will see only one order, that is in order. So we are going to show the output to user that we have created one node. So after this create node, we can write this in order traversal function. In order traversal, we have seen this yesterday. In order means root will come in between left and right child. So same thing we are going to write here. Void in order traversal. This is complete. Don't give space in between this. In order traversal is the complete word. In bracket, Here we are going to pass the root value. So what is the data type of root? Struct node star. So write it as it is and then root. Then inside this function we are going to check the root value. Initially whether your root is empty or not. Root is equal to null means we have not created any node. We have not got the address for the particular root or first node. That time it will return as it is, blank. If root is equal to null, equal to, two sign is there. If it is null, then it will give blank result. It will not showing anything. But if it is not null, if your root has some value, means we have created any node, that time we will apply this formula. In order traversal is equal to root left. We have to apply this in order traversal formula. So as per the in order traversal, first we have to visit to the left side. That's why I have written here root left. We will go to the left side first, complete that tree in order fashion. Then we will come to the root data. And after completing this, we will go to the right side and there also we will complete that subtree in order fashion. So this is the code for in order traversal. Done?
Just wait for 30 seconds.
Okay. When you will done, tell me.
Done, ma'am.
Done. Now we have written this function. So in void main we have to call this function to see the output. This we have to see this node now. So to see this node, we have to call this function from void main. So here we will call the in order function from void main. In printf, we will write in order traversal because we are going to show three traversal in order, pre-order, post-order. So for the separation, I have written here printf in order traversal. Give the slash n so it will show the separate result and call the function in order traversal in bracket root. So here through the function we are passing a root address. What address we got using that create node function, that address we are passing here in order traversal. Here inside this in order traversal we have used a recursive function. Till the end of that function, we are executing the same function again and again. Same thing is for right side also. Till the end of that side, we are going to call the function again and again. So this, if your function name and this name is same, then we are saying that this is a recursive function. And as in terms of structure, that is self-referential structure. Same name is there, so that is self-referential structure, and same function name is there inside the function definition. So it is called as a recursive function. So done this, now execute the program. Here,
Ma'am, can you go back 1 second?
just a minute. Here you can see the output in your order traversal. One node is created. Okay? Only one node we have created. So that node is shown in output. Every student has to complete this program. After completion of this, check your output. One should be your output. Done?
Yes, ma'am.
Have you seen output? Output is 1 here. Because only one node is there, that is a root node. So 1 is the output. Done everyone?
Yes, ma'am.
Now we will create another node, that is a left child. So here insert left as well as insert right. Both we will do. Before in order, before in order traversal. Insert left. Here we are going to create the left child of root. And insert right. This is a right child of root. Insert left, single word, insert left in bracket root comma 2 semicolon. Then next line insert right, single word in bracket root comma 3. So this is the calling part. Where is the definition? We have to write it. So definition part for insert left and right. Yeah. First, this is insert left child. So same, our data type is same, struct node star, because we are going to return this type of value. So this should be data type. Then insert left is your function name. Then inside this function parameter, first is root parameter. So data type we have to write there struct node star, comma, value or data of that particular node, left node. So that both are passing from parameter through void main. Inside this, where we are going to create that child left side of root. So root left is equal to create node function that we have already created. So same function we are calling from insert left function also. and return root left. Same, you can copy this code and paste it here. Wherever there is a left, you have to write there right, R-I-G-S-T. Only this thing is changing, left and right. Everywhere, inside the definition also. There is a root left, there is a root right. Same, return a root right. When you will complete, tell me. Done? Is everyone
Yes.
check the output? Three nodes should be there in order fashion. See, one is your root, left side is the left child, that is 2, and right side is the right child, 3. So in this sequence only you are getting the result. In between is your root. This is your left child and this is your right child. So in order fashion you are going to tell that only. 2, 1, 3 is the in order traversal result. So done everyone?
Yes, ma'am.
Again we are going to insert one more node, that is 4, to the left side of root. Already we have a root, then already when we have created this left child also, to this left child we are creating this node, new node, 4. Code is already written now, no need to write functions. Just write this line, insert left in bracket, root left, comma 4.
Ma'am, can
Then
you scroll up once, please?
what?
Can you scroll upwards once, please?
Where?
Ma'am, here only.
Done?
Yes, ma'am.
So after writing this line, left child of the, already one is left child is there, to the left of that child we have inserted 4 number. So 4 will come first in output in order fashion. 4 is there, then 2, this is the main root, and these two are the left child of this one, so that are coming first. Then 3 is the right child, so it is coming Next, check your output also in order traversal 4213. Done everyone?
Yes, ma'am.
So same way we are going to show the next order, that is pre-order. Pre-order traversal. Now you have all the code, only we have to change the order of that function and change the name of the function. First write this call printf pre-order traversal. Then pre-order traversal is the function name in bracket root. Done this line pre-order traversal in bracket root. Already we have code, try to copy paste it. Only change the name of the function. Done?
Yes, ma'am.
Now this call is there but definition is not written. This pre-order traversal definition is not written. So we have to write it now. Pre-order traversal. It is same like in order, only the thing where we have to write printf statement, that is a root part, will be different. In same code you have to copy paste in order, change the name of your function. Here code is same, change the name pre-order traversal. Then only pre-order means your root will come first, pre. So printf statement will be first, then root left and root right. And here also change the name pre-order traversal. Third function you have to write post order traversal. Only you have to change the name of the function and printf statement. You should know the where printf statement should be. When you will complete this, check your output for pre-order also. Done? Yes, everyone. Complete?
Yes, ma'am.
Check the output. Here. In pre-order, a root will be first, then one is the root. Then we will go to the left side. Left root is this, and this is the child of this root, left child. So after root, we have to finish the left child, then right child. So it does not have any right child, so we will go to the root again, and this is the root right child, 3. So 1, 2, 4, 3. is the pre-order traversal. Now you complete post-order traversal. Here, only write the name post. This thing will be same. You complete it. Wherever there is a pre, in that part only we have to write post. Done post order. So here same I am doing. Copy and paste. Here wherever there is a pre, there I am writing post. This is post order traversal. Function definition also. Function calling post order traversal. So after this we have to write the definition because we have written only calling part. In order, pre-order, after that, write copy this function directly. Pre-order, paste it here only after the pre-order. Change the name, post. Wherever there is a pre, you have to write post. This thing will be same. Now you have to tell me where to write print. Where to write print? Print means your root location. In post order, where should be your root? When it is going to come? Answer me. When this printf is going to come. No? In post order, first we have to visit to the left side, that is this one. Then right side,
Below left command.
at last we are going to show the root. Only this part you have to change, otherwise this whole function is same. No change in that function. Code is same. Only arrangement of this printf statement is different and your function name. So execute this. So this is the post order. In the post order, first left tree will complete. Left side, 4 is the leftmost child. Then 2 is the root of that subtree. Nothing is at right side, so directly it will show the root part. After that, 1 is the root, but it is not going to show the main root first. It will go to the right subtree. So at the right subtree, we have one node, that is 3. And this is the main root. After at last only your main root will come. So this is the result of post order traversal. Check everyone, you have got the same result or not. Everyone, Yes, done or not?
Yes, ma'am. Done.
So this is the basic program of tree traversing. So main thing is common in every tree. You can check your lab book also. What are the programs are there? So this thing will be common. Structure, this first two line structure, then create node. This thing will be common. Only your functions, other functions will be changed. As here I have written in order traversal. There will be, you have to count the leaf node. Only leaf node you have to count. So accordingly, your these functions will be changed. Other main basic thing is same. How to create node. This will be same. So if there is any doubt regarding this program, you can ask me.
No, ma'am. Ma'am, can you show us the whole program once?
Here also or in notepad.
Ma'am, in notepad चलेगा.
Just a minute. If you want to take a print screen, you can take it.
Ma'am, scroll.
Done. And
Yes,
last
ma'am,
part,
scroll.
main function.
Thank you, ma'am.
Okay. So here our tree chapter is finished with theory as well as one practical. Pramod sir is there? Yes, sir. Pramod sir. Sir is not there, right? Common?
Yes, ma'am. Sir is not there now.
Okay. Then we will end the meeting. We have finished this chapter here. Thank you very much.
Thank you, ma'am.
Thanks for.
Thank you, ma'am.
Thank you, ma'am.
सिद्धार्थ अपना रोल नंबर बताओ तो कौन सा है क्लास में